in marine sponges, and we will all try to understand it. She will give it to us in lay terms. All right, another round of applause for her, please.
All right, good afternoon, and I'm really honored to be here. So today I would like to share with you my research proposal, which is all about exploring gene regulation in marine sponges. So what are marine sponges? That's my title. Sponges are the oldest animals. They've been around for about 650 million years, so they are much older than cnidarians, which are your jellyfish and corals, which all of you might be very familiar with. And they are much, much older than bilaterians, which would include your insects, your worms, mammals like the mouse, and even us, the humans. So they're very old, and we have a lot to learn from them. So what else makes sponges special aside from being very ancient? They are, as you can see in this image, they are very diverse in their color and shape. And you've probably encountered some of these if you've gone snorkeling or diving around coral reefs. One unifying characteristic of all sponges is that they are immobile, which means that they are glued to the bottom of the ocean floor. They can't move around. They don't have any real tissues or organs like we do. And how they feed is they filter the surrounding seawater for food. Because they can't run around to escape their enemies or predators, they have developed really clever ways to protect themselves. And as such, they have become really physiologically and chemically complex. In fact, sponges are known to be called the drugstores or the pharmacies of the ocean because they make so many different kinds of chemicals. Sponges are also very important in marine ecosystems. So why should we study sponge genes? Well, first of all, they are ecologically and economically important organisms, like I already mentioned. And they are an ideal system for studying environmental effects because they're just sitting there, they can't move around, and because they filter seawater for food. They're also really rich sources of potentially useful compounds that can be developed as drugs or anti-cancer therapies. So there's really a lot of interest in sponges. So my research strategy is to use recently developed sequencing techniques so that we could identify and measure the genes in the sponge in response to changes in their environment. You might think because the sponge is just sitting at the bottom of the ocean that it lives a very boring life. But in fact, sponges really have a lot of challenges in store for them. So for a moment, let's imagine that we are a sponge. This is the life cycle of the sponge. And right after being released from the mom, sponges swim around in the open ocean where they have to deal with water currents, and they might get eaten by fish if they're not lucky. After a while, then they have to find the perfect spot to settle down. And this spot has to be the perfect spot because that's where they're going to spend the rest of their lives. And then after finding that spot that they want, they then glue themselves to that rock or that piece of coral. And then they begin the transformation into the adult form. This transformation is known as metamorphosis. As you can see, the adult is very different from the young sponge. As an adult sponge, all you do is grow and feed, and you have to protect yourself from your predators or competitors. And this is the time when you make all those different chemicals to protect yourself. So as you can see, each of these stages in the life of the sponge brings with it its own challenges. And the sponge is able to use its genetic toolbox in order to deal with all of these different challenges. And we hope that by studying how the different genes in the sponge are used during each of these different stages in its life, we'll be able to, first of all, contribute to improvement of our methods for resource monitoring and conservation, because when we know which genes change the most in response to environmental conditions, then we can design better ways of monitoring the health or the condition of our marine organisms. Furthermore, the identification of genes that are involved in the production of useful substances will also help us to design better ways of producing drugs, for example, or for synthesizing different types of materials that would be useful for all of us. And so I hope that this study will be able to contribute not just to improving our own lives, but also to improve the life of marine life, essentially. So thank you very much.